Find the real zeros or roots of the function gx, x plus 6 cubed, x minus 80 squared, 4x minus 7. Next to each root, state the multiplicity of that root. Then find the degree of the function, the whole function, and the maximum number of turning points. Then describe the end behavior of this function. So let me write down, let me first find the real zeros of the function and then their multiplicity. So make a table. Okay, let me draw slightly better. So here is the zero or root and multiplicity. Let's go back to the function. So we have 1, 2, 3 terms, 3 factors, sorry. We have 3 factors, and x plus 6 becomes 0 when x equals negative 6. Negative 6 plus 6, 0. So negative 6 is a root or 0, and cube means it comes 3 times. So multiplicity is 3. X minus 8 becomes 0 when x equals 8. 8 minus 8, 0. So 8. And square means multiplicity 2. It comes twice. So 8, 8 are 2 zeros. And 4x minus 7, let's do a little bit of work here. 4x minus 7 becomes 0 when x equals what? Let's find x. Minus 7, add 7 both sides. So 4x equals 7. Now divide by 4, 7/4. So from the third factor, we get the 0 or root 7/4. And there is power nothing means 1. So multiplicity is 1. Okay. Then it says find the degree of the function. What is the degree of this function? Degree of the function. We can add the multiplicity 3, 2, 5, 1, 6. Or we could have gone here. This is 1 plus 2, 3, 3, 6. If we multiply all the terms out, the highest exponent will be 6. 6th power, x raised to 6. So that's why the degree 6. And maximum number of turning points. So when we graph a 6th degree polynomial, it can have one less. Okay, one less turning points. So 5 turning points. The maximum number of turning points, okay, 1 fewer than the degree, so it will be 5. Then describe the end behavior of this function. Okay, so we have the degree 6. 6 means even degree. Okay, this is even number. And if we multiply out, look, x in the first place, x in the first place, x in the first. So we'll have even degree, we'll have positive. Leading term will have positive sign, positive and even. And we know whenever we have even degree polynomial, so it rises in both sides. If the leading term is positive, and if the leading coefficient is negative, so it would fall in both sides. So we have 6, so it could be this or this, and at the same time x in the first place. When we multiply out, so we'll get the first term positive, so we'll have this. Okay, so we write in this way the graph of the function. The rises on the left and also rises on the right. That's the end behavior. We don't know what happens in the middle, but eventually both sides go up. I want to give you one more information. This is it. Okay, whenever we find the root, then we can this is optional information, we can write down the nature of the root. Okay, since this root has multiplicity 3 or multiplicity, then the graph crosses the x-axis at -6. So crosses the x-axis at -6 because the multiplicity is 3 negative, so crosses the x-axis, okay, at -6. At 8, the root is 8, the multiplicity is 2, even means it just touches but does not cross, touches the x-axis but does not cross. And 1 odd is like this, crosses the x-axis. All that means when we graph this function at -6, I don't know, somewhere here, the graph, if it is going up, right, eventually, so it will go through x-axis. This is the x-axis, so it will go through -6. Same thing, 7/4 somewhere, it goes through 7/4. It could be coming from top, I don't know if it's coming to this one or this one. But at 8, somewhere here, 8 is 2, so touches but does not cross, means if the graph is above the x-axis, so it just comes there and goes back, or if the graph is below, it just goes up to that point and comes down. Okay, that's all I wrote here. This is optional, this was not asked in this question.